Okay, so just a warning, this is going to be quite a long video. So we're now on to the last part of logarithms and how we can use them for non-linear data and how to be able to plot them and use it. So there are two different cases. So we're going to start with case one that has this form here. So the x will be the base number, and then you've got the a and the n. I've sort of written little steps of how it works and how we can then make them more linear to be able to plot them and stuff like that. And I will have an example here, but I've sort of gone old school and printed it off, and I'm just going to stick it there. So the first type that we have got is this one. So y equals a to the x to the power of n. Now what I've done afterwards is I've done logs to both sides, essentially what I've written, and then I've simplified it so that it can look fairly linear, okay? And the reason why this looks linear is, think about like plotting straight line graphs. This is your y part. This is your y-intercept, okay? The n is your gradient, and this part is your x, okay? So the n will be the gradient part, which is essentially what I've written underneath in black. So the n's the gradient, this is the y-intercept, okay? And these are your x's and y's. Now the reason why we can plot them is because on the axes, rather than having x and y, we can have log x and log y, that's allowed. And you'll see how I'm going to apply it to the question that's going to be there. But it's quite good to write that down and make sure that you understand the steps. Now these parts are just me showing that I've used the rules that we've done with logarithms. So there's nothing particularly difficult after that. So first example we're going to do is this one here. So I might, oh that's annoying. I'm going to slightly cover it. Okay. It's quite long-winded. I'm just going to move it up a tiny bit so you can see it a little bit clearer. So this table shows about population in the UK's largest cities. It does say that London isn't on there because it's classed as an outlier. We don't need to worry about it at the moment. So we've got the cities, the ranking, so where the amount of population, and the actual population underneath. Okay. Just to sort of clarify, I have written up here that it's log base 10. Now you're always going to be doing log base 10 for these sorts of questions. And the reason why it's quite good for this one is because of this is going to give us a really nice number, because log base 10 of 1 million is 6. Oh, I can't do my words today. Right, okay, so part 1 says we've got to draw a table of the values of log r and log p to 2 decimal places. So that's what I've written here. Now this bit is literally just calculator based. So we're going to go through each one. So the 2, the 3, the 4, the 5 and the big numbers on the bottom, and type them into a calculator having base 10 and seeing what value it gives us. Okay, so I'm going to put it here so you can, I'll leave it there. So for the first one, we're going to do the Birmingham. The rank is 2. So log base 10 and then write 2. And it gives me that. Now for the table, it says 2 decimal places. That'll just be 0.30. Okay, I'm going to do it in red for the R's. So 0.30. Okay, you can just quickly go back and change it. So that's going to be 3. So that's going to be 0.48. And then 4, 0.60, 5, 0. That's going to be 70, and 6, 0.78. Okay, so that's the first bit done. So literally I've just done log of 2, 3, 4, 5, 6. Then I'm going to do exactly the same with these ones. So go back. First one is 1 million. 5, 6. There you go. So we get a 6 there. Okay, and we're just going to write it underneath the log of 2. Okay, just to keep them in pairs. Obviously, that's what we're going to be using to plot them in a moment. Next one. 73. How many zeros is there? 4. 1, 2, 3, 4. 1, 2, 3. Yes. 5.86. 5.86. Next one, Glasgow, 62, 5.79. Gets quite tedious after a while, just keep going, you'll be fine. 5.3, 5.72, 48, 5.68. There we go. So there are our values. Okay, they don't go down by a lot. So next one, part B, we need to plot the R against the P. So the top one, think of those as being your x's, okay, so they're going along the bottom, and your population, the log of P, is going up the side. Okay, I'm going to move up a little bit so you can see. I have done a squiggle just because obviously the decimals are quite small, so I just thought I'd add that in. So we're just going to plot them one by one. So 0.3 and 6 up. Have I got the red on? Yes, 0.3 and 6 up is there. Next one, 0.48, so roughly there. And 0.586, it's going to be about there. Okay, just be as accurate as you possibly can. No one can be perfect. 0.6 and 0.8, just under 0.79. 0.7 and 5.7. It's going to be 5.7 there, 5.72. And 0.78 is going to be there. 0.68. So just under. Okay, need to quickly get a ruler. There we go. Okay, so it does say that we also need to draw a line of best fit. So just try and get as best you can along the line. I'm going to do it in black just so you can see it quite clearly. Yeah, I'm going to say about through there. Okay, obviously everyone's going to be slightly different, but more or less it's quite a nice line. Okay. So I'm going to move it down just slightly just so we can see part C. So part C, use your graph to estimate the values of A and N to two significant figures. Okay, so we're going to start off with, I'm going to rearrange. So we've got the relationship. So in the question, I'm just going to write that down. Okay, and I'm going to rearrange it like what I did right at the beginning at the top for the case 1 bit. So P equals A R to the power of N. Okay, so I'm going to take logs of both sides so that I've got the P and the R in it. So log P equals log A R to the N. Okay, now I'm going to simplify the right hand side just because I don't like it being together and stuff like that. So the left side is going to stay the same. This one I can split the A and the R to the N. So it'll be log of A plus log of R to the N. And I can simplify further so the N can come to the front. Okay. So that's just showing me that I've got, this is like our Y, think of it like that. This is our intercept. This is going to be the gradient, the N, okay? So we can start with the A part quite easily. So this is just like your Y-intercept, okay? So looking at our graph, we can see that if we go along, it goes through 6.2, okay? So that means that our A, or log A, is going to be equal to 6.2, okay? Obviously, I'm just going to put a line down here. You'll see why in a sec. We need to find out what just A is, okay? So this at the moment is base 10. So this means that A is equal to 10 with this power, okay? Which is equal to, if you put that into a calculator, 1, 6, 0, 0, 0. How many zeros is it? 5. Okay, remember we have to do it to two significant figures, sig figs. Okay, so it's just remembering, oh, can you see that? Yeah, there we go. Okay, so it's just remembering the laws that it's the base and that's the power, and that gives you what A is. Okay, so that's that bit done. We need to find out what N is. Now the N, as I said before, is the gradient. Okay, another way to do that is we do have a line here, so we can draw a line like back in GCSE. and we can then draw a triangle and then work out the gradient that way. So it doesn't matter how large the triangle is. I'm going to go for here, I think. Okay, so my triangle goes along. There we go. And we've got this here. So remember, it's the difference in y's. So the difference in y's is going to be these bits here. So n is going to be 6.2. Oh, wrong way around. Because you're going down. Sorry, my fault. So 5.8 subtract 6.2. Okay, and the difference in x's, so that's from 0 to, so it'd be 0.6, take away 0. Okay, so that's going to be minus 0.4 divided by 0.6, which is 0.67, I think. But I'll check just in case, because it's on video. Yes, minus 2/3. Minus 0.67. Okay, so just be careful with the n. You don't need to do the loggy bit, okay, because the n's at the front is just going to be a number or a decimal. This one you do need to do the log part because it's log a, it's not just a on its own. Okay, so the more practice you do though, the better you'll get. So that's the first bit. Okay, I'm just going to turn over because there's actually another case. Okay. So case 2, slightly different. So this time, rather than x being the base, x is now the power. Okay, the bits that I've done afterwards are exactly the same. So all I've done is take logs of both sides, split the logarithm of these two, so we've added them, and then brought the x down. So this one's slightly different in the sense that now the gradient is the x part. The gradient is the log part. Okay, which is log of b. Okay, log of a is still the y-intercept, which is normal, and that's still the same as well. So it's just that part. Rather than n being the gradient, you've got log of b being the gradient instead. So we're going to have to do the log thing like we did before, okay, for the y-intercept. So for the example, it's this one here. So this one we're given the graph already, which is quite nice. Okay, so for part A then, we need to write down the equation of the line. Now this one sort of, you just got to read the blur and actually you'll be able to work it out quite nicely. So your axes, this is a t, it's not a very good t. Okay, so on the left we're going to have log of p, because that's what it says on the old original y-axis. Okay, so that's going to be log p equals. The gradient we're told is 0.6 in the question, so it's going to be 0.6. Okay, and we look at the x-axis and they've called that one t, so it's going to be 0.6t. Plus the y-intercept, so the y-intercept, it crosses the log p axes at 2, so we're going to write plus 2. Okay, so that's the answer to this one. So the first bit is just this, look at the y-axis and see what they've got. So they're obviously doing population, but they've taken the logarithm of it. Then we look along here, so it's in terms of t. The question tells you the gradient is 0.6, so that's why we've got 0.6 there. Okay, and it crosses, they say the vertical axis, but think of it as just the y-axis. That's where it's crossed, okay, so that's where the plus 2 has come from. So for part B, so we have been asked, using your answer for part A, find the values of A and B, giving them to 3 significant figures. So this is quite similar to what we've just done. Now, I don't want it to be log of P, okay? The first thing I want to do is find just P. Okay, so to do that, remember this actually has a base 10. So P is equal to 10 with this power, 0.6t plus 2. Okay, I need to simplify it because we can't have the +2 here because it's not in the form that we want, because they are wanting this form from the question. Okay, so we're going to have a number and then another digit with a power, okay, which is going to have the t involved. Now, thinking of rules of exponentials, we can split this up by writing 10 to the 0.6t multiplied by 10 to the power of 2. So when we're multiplying powers, we're adding them. So all I've done is done the reverse. I've split them up, okay? And we can actually work out 10 squared is going to give us 100. So it's actually 100 multiplied by this part. Now this can't be simplified anymore at the moment. Okay. So I don't like it being 10 to the power, so I am actually going to work out what that is. So on a calculator, so 10 to the power of 0.6, 3.9, how many decimals do we know? 3 sig figs, so it'd be 3.98. So 100 times 3.98t. So all I've done is put this part into a calculator, okay, just so that I have the t, which is what they want in the question, there. And then we can just say that, so this part which represents the a, so a is 100, and this part which represents b, so b is 3.98. Okay. So, final part, the bit that some people absolutely love. I'm not a big fan of meanings. So interpret the meaning of the constant of a. So it's asking, what's this 100 about? Okay, so this 100, that just represents the number of bacteria at the beginning. Okay, so you've always got to relate it back to the question. So this is talking about the growth of bacteria. So this is what it started with when time was 0. Okay, so different ways of writing it. I'm going to just say this is the initial bacteria population. Okay, it doesn't need to be a whole essay, just a few words. Okay.